All right, as we start to get to the end of chapter 8, we're still going to be dealing with right triangles, but we're going to deal with how do you solve for these missing sides in right triangles if you don't have enough information to use the Pythagorean theorem, or if you don't have enough information to use one of our special right triangle shortcuts. So if that's the case, we use what we call trigonometric ratios. These are just ratios of the lengths of two sides of a right triangle. There are a whole bunch of different trig ratios. In this class, we're going to talk about 3 of them. So they are sine, cosine, and tangent. The sine of an angle is always going to be the leg opposite that angle divided by the hypotenuse of the triangle. So in this triangle, if I'm looking at the sine of angle R, I would take the leg opposite it, so that would be lowercase r, and I would divide it by the hypotenuse. Our next relationship is cosine. Cosine is adjacent divided by hypotenuse. So if I were finding cosine of r, adjacent just means next to. So I would take this side, s, and divide it by the hypotenuse, so lowercase t. And our last ratio is tangent, just abbreviated TAN. Tangent is your opposite leg divided by the adjacent leg. So tangent of that angle R would be lowercase r divided by S. And you'll notice the way this triangle is labeled. I know it's kind of small, but we label the angles, the corners of the triangle, with uppercase letters. So this is RST. Sides are labeled with lowercase letters, and we label the sides based on the angle that they are opposite. So the side across from angle T is lowercase t. The side across from angle R is lowercase r. And the side across from angle S is lowercase s. All right, so these trig ratios are so helpful just because your calculator has memorized them and does all of the work for you. We just have to know what to type into our calculator. There is a memory trick to remember these, and there's actually a bunch of different memory tricks. I just remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I just write that across the top of my paper. You might hear me say SOHCAHTOA. That's how I remember how to say these. Again, there are other memory tricks out there, so you might have something else that works for you, but you'll tend to see me write this out quite a bit throughout this chapter. So first thing I want to do with these, I just want to find the ratios. So looking at triangle ABC, we're going to find sine, cosine, and tangent of angle A. So angle A is up in this corner. Sine is the relationship of the opposite side divided by the hypotenuse. So the side opposite angle A looks like is 12. And the hypotenuse is always going to be our longest side, the side across from the right angle. So 13. So in this triangle, sine of angle A is 12 divided by 13. Then I want to find cosine. Cosine is adjacent divided by hypotenuse. And adjacent just means next to. So this is angle A. Technically, there are 2 sides next to angle A. We've got AC and AB. But we know AB is the hypotenuse. So the adjacent side is going to be AC. And then the hypotenuse, I just told you, was AB. So that relationship would be 5 over 13. All right, and then tangent would be opposite over adjacent. So again, we're looking at angle A. Opposite is 12. Adjacent, meaning next to, is 5. So that would be 12 over 5. And these are the trig ratios just based on angle A. If I found tangent of angle B instead of angle A, it would be a completely different number. All right, so now we are going to use these ratios to solve for missing angles or to solve for missing sides. So in these two cases, I want to find x, and I'm going to round to the nearest hundredth if I need to. So go based off the angle you have. We can never use the 90-degree angle, so just keep that in mind. So we're looking at angle A in this case. I need to use one of those trig ratios, sine, cosine, or tangent. So we're just going to see which one applies. And that's TOA. So it looks like I've got this side, CB is x. Well, that's directly across from my 36-degree angle. So that would be an opposite side. And then the other side I have is the one next to angle A that's not the hypotenuse. So that would be the adjacent side. So I need a trig ratio that will tell me about opposite and adjacent. That one's going to be tangent. Then we're just going to write an equation and plug in the stuff we know. So I know that the tangent of angle A, which in this case is 36 degrees, is equal to the opposite side, x, divided by the adjacent side, 7. Tangent of 36 is just an operation that we're doing to 36 degrees. It would be like taking the square root of 36 or multiplying 36 by another number. So we're just going to treat that like a number in our algebra. I want to solve this for x. So in order to get x all by itself, I would multiply each side by 7. That's going to cancel. So I know x is equal to 7 times the tangent of 36. That is actually my answer. But remember in the problem, it asked us to round to the nearest hundredth. So we're going to type that into a calculator. There's not really a great way for me to show this to you in a video. So if you need help putting it in your calculator, please ask in class, or you can probably Google where is the tangent button on whatever your calculator is. But I'm just going to type in 7, press the tangent key, 36, close the parenthesis, and I got 5.0857. Round to the nearest hundredth would be 2 things after the decimal place. So we will call that 5.09. All right, let's do the next one. So looking at number 10 here, I'm solving for x. So you're going to use the angle that we have. So it looks like we've got angle W. Figure out what relationship we have here. So the side that is 12 units looks like it is directly across from angle W. So that would be our opposite side. The side that's labeled X is directly across from the 90-degree angle. So that would be our hypotenuse. So I need a trig function that tells me about opposite and hypotenuse. That's going to be sine. All right, let's use it to write an equation. So the sine of 63 is equal to the opposite side, which is 12, divided by the hypotenuse, which is x. All right, I've got an equation and I want to get x all by itself. I'm going to start by just getting rid of this fraction. So to undo that fraction, I'll multiply each side by x. That'll cancel on the right. So I know x times the sine of 63 will equal 12. And then again, sine of 63 is just an operation we're doing to 63. It's just like taking the square root of 63. So we're just going to treat that like a number. So to get x by itself, I'm going to divide each side by the number sine of 63. So that's going to cancel. I know x equals 12 divided by the sine of 63. That's my answer, but I want it to the nearest hundredth, so I'm going to type that in a calculator. 12 divided by sine key 63, close your parenthesis. And again, this is something where you might need help finding that button in your calculator. So ask me the next time you're in person, or if you're IDL, send me an email and we'll get you figured out. So I got x was about 13.47. All right, I think I have a couple more examples because these ones are a little tricky. So here I want to find the measure of an angle. We're going to follow pretty much the exact same process. So I want to find the measure of angle T. So that's the angle I'm finding. Look at the information that I'm given. It looks like I have an opposite side and an adjacent side. Again, I have to figure out which trig function I'm going to use. All right, so the function that tells me about opposite and adjacent is going to be tangent. So that's the equation that I'm going to set up. We know the tangent of angle T, which is what I'm trying to find, is equal to 14 square roots of 3 over 34. Now I want to solve this for angle T. So I have to somehow undo tangent. Remember, tangent is just an operation that's being done to that angle. So I'm going to undo it by taking what we call the inverse of it. So I do tangent inverse of each side. And again, this is an operation. It's like undoing a square root by squaring both sides. Or undoing dividing by 2 by multiplying both sides by 2. So tangent inverse of tangent, those two things would cancel and just leave me with T equals tangent inverse of 14 square roots of 3 over 34. Again, that is my answer, but I want to find the measure of this angle to the nearest tenth. So I have to put that in a calculator. Chances are if your calculator has a tangent key, you'll use the same button for the inverse tangent. You're just going to have to press second beforehand. And again, this is something I can show you in person if you need help. So second tangent gets me to tangent inverse. And then in my parentheses, I'm going to type 14 times the square root of 3 divided by 34. I got 35.5 degrees. And we're going to do one last example. So in this one, I'm trying to find angle T as well. Let's look at the sides I'm given. 7 looks like it's opposite. And 18 is right next to T, but we're not going to call it the adjacent side because it's actually across from a right angle. So that's going to be the hypotenuse. The trig function that tells me about opposite and hypotenuse is sine. So we're going to use sine in this one. Let's set up our equation. I know that the sine of angle T will equal 7 over 18. I want to solve this for T, so I have to undo sine. You can probably guess, in order to undo sine, I'm going to have to use sine inverse. And again, this is an operation that I'm doing, so I have to do it to both sides. It'd be like if I multiplied one side by 2, I'd have to multiply the other side by 2. So sine inverse of sine of T, that's going to cancel. I'll just be left with T. And technically that's the measure of angle T, is sine inverse of 7 over 18. That's my answer, but I want it to the nearest tenth, so I'm going to throw that in a calculator. And again, you probably have to press the second key and then the sine key on your calculator. This one looks like it's 22.9 degrees.